Okay, this video will talk about conjunctions and disjunctions known as compound inequalities. So we'll start with conjunction. The criteria for being in the solution set of a conjunction is associated with the word and, disjunction is associated with the word or. So let's define them first and look at some examples. So in a conjunction associated with and, both conditions must be true. So both conditions must be true, and you can express this as one inequality. A disjunction, on the other hand, the criteria for being in the solution set is at least one condition must be true. At least one condition must be true, and to express a disjunction, you need to use the word or. Whereas with the conjunction, you can write it without the word and. So let's look at simplifying some of these. So here's your conjunction over here. -1 is less than x plus 1, which is less than or equal to 4. Notice how I can write this as one expression. And the way I simplify it, I'm still isolating the variable, but I'm isolating the variable in the middle of the expression. So I would subtract 1 from all three spots. And then I end up with -2 is less than x, which is less than or equal to 3. To graph this, simply draw a number line. And your number line can actually mimic your expression. You have -2 and +3. I have strictly -2 is less than x, so that's an open circle. And x is less than or equal to +3, so that's a solid circle. My solution set is the range of values between the two boundary points. So my solution set here is a continuous range of values. So it's the range of values between, but not including -2, up to and including -3. The disjunction on the other column, you can see it's expressed with the word or. So you would isolate the variable in both expressions, and let's analyze what this graph looks like. So I would subtract 1 and divide by 5. So 5x is less than -5, therefore x is less than -1. And then simplifying the other expression, 3x is greater than 9, x is greater than 3. So to graph this, you draw your number line. You have -1 and +3. The first expression, x is less than -1, is an open circle, and then you shade in the direction of -infinity. And then the other expression, or x is greater than +3, an open circle, and then shading in the direction of +infinity. So you can see that there's a gap in the number line. There is not a number that fits both criteria at the same time. So I would use the word or. And then you can compare the disjunction graph to the conjunction graph, and you can see, and, well, I do have a set of numbers that will fit both conditions simultaneously. And in the other, the or scenario, I don't have a single number that fits both conditions simultaneously. So you can see one graph contains the boundary range shaded between the boundary points. The other graph marks the boundary points, but then you shade off in the direction of both positive and negative infinity. And looking at the special case, the no solution case, just think about this. I have x is less than 5 and x is greater than 5. If I try to write this as a single expression, it doesn't make any sense. And if I plot 5 on a number line, and I'm expressing the fact that x is less than 5 and x is greater than 5 but does not include 5, there is no number that fits this description. So there is no number to satisfy this. So this is a no solution. No number is both greater than and less than 5. So it's kind of common sense. But sometimes that happens in your outcome, and you need to know to interpret that as a no solution scenario. And then in the disjunction side, you can have an outcome where the solution would be all real numbers, where the number that you're describing it can be found on the entire number line. The situation being described includes all real numbers. So here, once again, using 5, well, I have x is less than 5, so I open circle there and I shade in the direction of negative infinity, or x is greater than or equal to 5. So then I come behind that, and now I'm graphing this, so I color the 5 in, and I'm shading in the direction of positive infinity. So suddenly I've covered the entire number line. So this is the situation where the solution would be all real numbers. And looking at the other page of the notes, it's just more basic foundation. And here you can see your conjunction side, finding a variable value that makes both inequalities true, and then a basic problem type, and then your disjunction, at least one must be true, and then problems that don't fit the standard. And then at the bottom of this page, you've got 2 scenarios where you actually need to think about the definition before you can claim your solution set. So this problem that's in the conjunction column, if I solve each piece, I could write this as one single string, but let's solve each piece, connected by the word and right here. If I isolate x on this side, I end up with this. And if I isolate the x over here, I end up with this. And then I draw my number line to try to graph and analyze my solution. Well, x is less than or equal to negative 3. So here's my number line with 2 and 3. Well, I'm going to close this in with a solid circle. Less than would imply I'm shading all of this direction in the direction of negative infinity. And I'll do this one in red. So here, I now have x is less than or equal to positive 2, shading in the direction of negative infinity. With this, the condition or the definition for conjunction is both conditions must be true. So they both have to be true. So that means here I need to go with the smaller range, because in the smaller range, both conditions are met. So the solution to this would be the graph x is less than or equal to positive 2. Because if I were to choose the larger range, I have a series of values right here. I'll do this in green. I have a series of values here in green where the condition over here would not be met. The condition on this side would not be met if I were to choose values right here. So when this happens with the conjunction, you would choose the smaller range. And let's look at the unexpected outcome in the disjunction. So simplifying each piece here, you end up with x is less than negative 3, or x is less than or equal to negative 5. So analyzing the graph, you draw your number line, and you have negative 5 and negative 3. X is less than or equal to negative 5, I'll do that one in blue. So here, solid dot in the direction of negative infinity to shade for my solution set. I'll do the other in red. I have an open circle at negative 3, and then I shade in the direction of negative infinity. Well, in this scenario, only one condition must be true. That's the definition of conjunction. Only one condition must be true. So here I could choose the larger range. So the solution for this would be x is less than negative 3, would be the solution for this disjunction.